So we're on page 109, topic 20. It's the first page of topic 20, and we're going to divide 109 into three parts. First of all, we're going to look at solving quadratic equations by the square root property. Then we're going to look at solving quadratic equations by the quadratic formula. And finally, we're going to look at examining the discriminant and what that tells us. The discriminant is b squared minus 4ac. So let's get started. First of all, solving quadratic equations by the square root property. If x squared equals, here is k, some sort of a number, k must be greater than or equal to 0, because otherwise we can't solve it. We can't take the square root of a negative number and get a real number solution. So if x squared equals k, then x equals plus or minus the square root of k. For example, if x squared is equal to 7, x is equal to plus or minus the square root of 7. So here this is k and this is k. And doing this is called the square root property. What this means are there are two solutions, the root of 7 and minus the root of 7. So if, for example, we go back and we let x to check this answer, we let x equal the root of 7, and we put this into the left-hand side, root of 7 squared, then it equals 7 on the right side. So that's what's shown here. Same thing if we take the other solution, which is minus root 7, and we square it. A minus times a minus is a plus. Square root of 7 times square root of 7 is square root of 49. Square root of 49 is 7. And the right-hand side of this is 7. So there's no real number solution for this square root of a negative number, and that's just simply here we say that the number has to be greater than or equal to 0. So now let's go to solving quadratic equations by the quadratic formula. So we have a quadratic equation, ax squared plus bx plus c equals 0. And we want to know the values of x that make this 0. That's what we're trying to find here. And the proviso is it can only be, we can only solve those equations for which case a does not equal 0. Because if a equals 0, it's no longer a quadratic formula. It must have this squared term in it. So the formula for this is if we know a, we know b, and we know c, then we use minus b plus or minus the square root of b squared minus 4ac over 2a to calculate the values of x that make this equation equal to 0. So supposing, as an example, we have x squared minus 2x minus 1 equals 0, and we want to find out what are the values of x that make this equal to 0. In this case, a is 1, because the coefficient of x squared is 1. B is minus 2, and C is minus 1. If we put this into the formula, we have minus B, and B is minus 2, plus or minus B squared, where B is minus 2, minus 4, A is 1, and C is minus 1. So we're just putting these values into this formula. And when we do that, minus minus 2 becomes plus 2. This is 4 plus 4. Both these terms are 4 and 4, and when we add them we get the square root of 8. And 2a is 2 times 1, so that's 2. Now the square root of 8 is equal to square root of 4 times the square root of 2, so we can take out 4 from this. We can, instead of writing 8, we can write 4 times 2, and the square root of 4 is 2, so we get 2 root 2. So 2 plus or minus 2 root 2, and we factor out 2 from the top. 2 times 1 gives us 2, and 2 times root 2 gives us 2 root 2. Of course, we have the plus or minus here. Then we can cancel the 2 in the bottom, so we have 2 solutions. We have the solution 1 plus root 2 and the solution 1 minus root 2. This is where in the manual the answer is checked. I'm going to do it slightly differently, but it's basically the same thing. I'm going to substitute x equals 1 plus root 2 into the equation. And the equation here is this one, x squared minus 2x minus 1. And that's the left side. You'll notice the right side is 0. I'm going to check it by putting that into the equation. So I'm going to substitute this answer into this equation. So you get 1 plus root 2 squared, because I'm substituting the x, 1 plus root 2, minus 2x is minus 2, 1 plus root 2 for the x, and minus 1. Now the first times the first is 1, and root 2 times plus root 2 times plus root 2 is plus root 4, which is plus 2, which is the last term. The inner and outer terms are both root 2, and when I sum them, I get 2 root 2. So this is the inner and outer. We're using FOIL, F, inner and outer, or outer and inner, whichever you prefer, plus the last term. And then minus 2 times 1 gives me minus 2, and minus 2 times plus root 2 gives me minus 2 root 2, and then I have this minus 1 is that here. So you can see that what happens here is the 1 plus 2 sums to 3, minus 2 minus 1 gives me 0, and this plus 2 root 2 and this minus 2 root 2 sum to 0. So the whole thing sums to 0, and the right side of the equation was 0, so the left side equals the right side. If I substitute in this one here into this, x squared minus 2x minus 1, again using the FOIL method, multiplying 1 minus root 2 times itself. 1 is the first term, and the last term is plus 2, because minus root 2 times minus root 2 is plus root 4, and the root of 4 is plus 2. So here now, when we multiply 1 minus root 2, and the middle term is going to be minus 2 root 2. It's just going to be the opposite of this one here with a negative sign. And here minus 2 times 1 gives me minus 2, and minus 2 times minus 2 root 2 gives me plus 2 root 2 minus 1. And here again what happens is 1 plus 2 minus 2 minus 1 sums to 0, and the minus 2 root 2 and the plus 2 root 2 sum to 0. So the left side equals the right side. Note that we can't factor x squared minus 2x minus 1, and in this case we use the quadratic formula. So we can't factor this, and as a result, to solve it, we use the quadratic formula. When you can't find the roots, then you use the quadratic formula. Now let's take this example here, a separate example. This is factorable, and we don't need the quadratic equation to get the solution. We've got x times x gives us x squared, minus 4x is the inner term, plus 2x is the outer term. It sums to minus 2x. And minus 4 times plus 2 gives us minus 8. So these are the factors. The solutions are x equals 4 and x equals minus 2. But supposing we thought that this was not factorable. Supposing we just said, oh no, I don't know how to factor this, and we used the quadratic equation, what would happen? Well, we put x equals minus b plus or minus b squared minus 4ac, root of b squared minus 4ac over 2a, and for this equation a equals 1, B equals minus 2, and C equals minus 8. A is the coefficient of x squared, B is this number here, and C is that. And we substitute into this quadratic equation with these values. We get minus 2 minus B, and B is minus 2, plus or minus B squared, minus 4A is 1, and C is minus 8 over 2A. So when you work this out, this comes out to be 4, and this works out to be 32 plus 32, so we get plus 36. So we get 2 plus or minus the root of 36. The root of 36 is 6. And we have two possible solutions, 2 plus 6 and 2 minus 6. 2 plus 6 is 8, divided by 2 gives us 4. 2 minus 6 over 2 gives us minus 2. Lo and behold, the answer we get from the quadratic equation is exactly the same as we get from factoring. Doesn't make any difference. It has to give us the same answer. So here I've checked the answer, x equals 4. Put it back into x squared minus 2x minus 8 equals 0. X squared is 16. 2 times 4 is minus 8, and this is minus 8, and comes out to be 0. The left side is 0, and the right side is 0, so the left side equals the right side. So x equals 4 is a valid answer. We check x equals minus 2 and put it into this equation again. Minus 2 squared gives us 4. Minus 2 times x of minus 2 gives us plus 4, and here we have the minus 8. 4 plus 4 is 8. 8 minus 8 is 0. The right side is 0. The left side equals the right side, so that works out. So that's just an important thing to realize, that if you get an equation, you can always use the quadratic equation. You can always use the quadratic formula to solve the problem and find what the values of x are that make the solution 0. The thing is that if you can actually do the factoring, okay, if you can actually do the factoring, which is right here, it's much easier, it's much quicker. So this takes time to do, but it'll give you the same answer. We're on page 109, and the last thing is to look at the discriminant. The discriminant is this part of the quadratic equation in here without the root sign. It's b squared minus 4ac. If the discriminant is 0, the equation has no real roots and no real solutions. So let's take this equation here, x squared plus x plus 3 equals 0, a equals 1, b equals 1, c equals 3. A is a coefficient of x squared, b is a coefficient of x, which is 1, and c is 3. We put that into the equation. Minus b is minus 1, plus or minus b squared minus 4ac. Now we really only need this part of the problem to see what's going to happen. 1 minus 12, which is minus 11. We can't take the square root of a negative number. You can't and get a real number solution. It's undefined. So there's no real number solution. In this case, the parabola does not intersect or cross the x-axis. So that's what that means. If this is negative, the graph does not cross the x-axis. Now here's an example. It's taken from the next topic, topic 21. But this is a graph here, y equals minus x squared minus 2x minus 3. We calculate the discriminant, which is b squared minus 4ac. That's what the discriminant means. So in this particular case, we get b is minus 2 squared minus 4ac is the coefficient of this, which is -1, and c is -3. You can see that this is 4 minus 12. -3 times -1 is +3. 4 times 3 is 12. We get -12. The discriminant is -8. So this means that the graph does not, there are no roots, there are no solutions, which means it doesn't cross the x-axis. Here's the graph here. And you can see what happens. It goes up like this, it goes down. It never at any place crosses the x-axis. So that's the key part to understand. If b squared minus 4ac is called the discriminant, if b squared ac is less than 0, which means it's negative, the equation has no real solutions, which means that there are no values of x that are valid for that, which implies that, or says that this graph does not, you can see this graph goes up. Yes, it crosses the y-axis, but it never crosses the x-axis. The origin is right here. This is 0, 0, right here. So do you see this graph going up? Do you see it crossing the x-axis in any way? No, it doesn't. Okay, so that completes our discussion of page 109.